We'll explore supply chain challenges and the critical role of strengthening India's domestic HVAC&R manufacturing. Moderating this session is Shruti Deora, Partner Climate and Gender Practice at IntelliCap. I would like her to invite her to the stage. Joining her are our other distinguished speakers on this panel. Pradeep Subramaniam, Senior Consultant at AEEE. Jerry George, Specialist, Cooling and Energy Efficiency at the National Research Development Corporation. Mr. Akash Agarwal, CEO of New Leaf Dynamics. And Snehal Kumar Suryavanshi, Head of Clean Tech India, Alpha Level India Private Limited. Please sit according to the order. All right, over to you.
Hello. Thank you and welcome everyone back from lunch. I hope all of y'all are awake. So we'll quickly get started with a little bit of context. Cooling is no longer a luxury. It is a development imperative important for India. Rising temperatures and extreme heat stress threatens lives, livelihoods, and economic productivity. The demand for cooling is set to increase 5.8x in the next 13 years, creating an urgent need for affordable and energy-efficient solutions. Despite this rapid growth, India remains heavily reliant on imported HVAC&R components, with domestic value chain additions in critical components and segments like room air conditioners currently less than 45%. Challenges such as limited access to high-tech manufacturing, lack of R&D investment, high capital costs, and economies of scale of global players have hindered our domestic manufacturing. Through this session, we aim to explore, one, what are the key bottlenecks in India's HVAC&R supply chain, what are the strategies for localizing production, and what are the pathways to creating affordable, highly efficient cooling solutions. So by fostering domestic manufacturing, India's can enhance energy security, economic resilience, and sustainability, ensuring equitable access to cooling while aligning with our net zero commitments. So let's just dive directly in. And my first question is for Jerry. Jerry, NRDC has recently conducted a study to analyze the technology roadmap for RAC and ceiling fans. So can you please elaborate a little more on some of the key findings from the study?
Thank you, and good afternoon to all. First of all, I want to thank AEEE for inviting and organizing this important session on domestic manufacturing of cooling appliances. So NRDC has been working on a technology roadmap for two appliances, basically room air conditioners and ceiling fans. We wanted to understand, this was like a long-term vision on how the current landscape of these two appliances look like and what are we looking at from a future point of view. So we looked at three parameters basically. What does the industry has to say about affordability, domestic manufacturing, and super energy efficiency. So I'll start with room AC. So firstly, for both the product, if I have to say one takeaway that is almost equivalent for both, is that both these products are a cost-sensitive market. And to do anything to do with indigenous manufacturing or even super efficiency, the role of research and development and innovation is the key. So that is something that was emphasized by all the industry players that we talked to. But starting with room air conditioners, firstly, if I talk about energy efficiency, so ICR is the metric currently that we talk about. So how do we see or what is the ceiling that we can hit in terms of improving this energy efficiency or ICR level year on year or every 3 years? So currently, if I take an example of 1.5 TR room AC, we have a threshold of around, like, we can achieve at least 6.2 ICR for a 1 TR and almost like a 5.8 ICR for a 1.5 TR. Even if we do like some component level enhancement and through component level changes, be it in the heat exchanger, coils, and etc., there is a scope for almost like a 10 to 15% improvement, and we can reach to like a 6.2 to 6.3 ICR, and maybe with little cost increment. But now if you have to move beyond, like to a 7 or 8 ICR kind of tech, then we are talking about integrating it with, for example, evaporative cooling or even a multi-split system. And that has been showcased by technologies like in the global cooling price as well. But again, with some cost increment. But then if we talk about like a long-term vision where we are talking about an ICR rating of 10 or 11, then we are talking about solar-assisted cooling or like totally disruption in the technology itself. So even though there is like an energy efficiency improvement and there is some correlation with the cost and pricing for that, but that's the current situation of where the efficiency for room AC looks like. Now if I come to the supply chain, so compressor and motors are like the major energy guzzlers, be majorly the compressor, and it is like almost highly reliant on import, and mostly it is imported. And so the major component that even if like through PLI scheme there is some interventions in terms of how we can promote domestic manufacturing, but most of the benefits of PLI scheme has been gone into production of sheet metals and even the plastic components of the room air conditioner, but which is hardly around 15% or 20% of the cost of the total equipment. So somewhere domestic manufacturing of compressors in India will be the key for room AC. And then there is this whole conversation from the Montreal Protocol lens in terms of which is the refrigerant that will be used in the future. There is a HFC phase down that India has committed to as part of the Kigali implementation. So even if we start to manufacture these compressors in India, but it has to comply with the HFC phase down schedule as well. So for example, there is this MLF funding that is available for enhancing energy efficiency while phasing down refrigerant or HFC phase down as well. But still, to access that, there is limited understanding from the industry, or even there is some challenges in terms of how do we access that fund and utilize it for energy efficiency. So Godrej in India has started some initiative on having an R290 compressors in India, but we'll see like that is an initiative that more and more should be maybe encouraged by industry to see how we can do that. And finally, on room air condition, I just want to touch upon that SNL aspect of standards and labeling. While I talked about like how do we enhance, how does the ICR rating in the future look like, how do we reach that 10, 11 ICR, but when we compare it to the global standards, I think there is some scope that if India wants to be the global best in terms of energy efficiency standards, then how can we make sure at least the 5-star is equivalent to the best available technology globally, or even in India for that matter. And for the MEPs, I think there is lot of things that India has to consider in terms of how the economy will play, what is the consumer preference, and what the pricing looks like. So that's my take on room AC to start with. On ceiling fans, I'll start with say that we are talking about 500 million ceiling fans. That is almost the current stock, and it is almost going to double in the next coming decade. So the opportunity is huge. Even if we go from a 75-watt induction motor fan to a 25-watt BLDC fan, I think the savings, energy savings numbers that we are talking about is almost in the tune of 20 to 30 terawatt hours in 10 years. So the opportunity is huge. It's a simple product for us, like ceiling fans mein kya ho sakta hai is the thing that at least we started with when we started this project. But it's more about induction motor versus BLDC technology right now. What is the current state of industry? For induction motor, it's like, how do we make sure that, is there a way that currently they're complying with almost the 1-star level of the B-star labeling, which is around 50 watt. But even to reach like a 35 watt, 40 watt, there is lot of support that the MSME needs in terms of capacity building and R&D. That how do they comply with the future revisions that may happen in the ceiling fan industry. On the other hand, the BLDC motors that are there, they are highly again dependent on the import dependency in terms of semiconductors and magnets that are used. So that is one challenge. But even if like, can India think about starting semiconductor manufacturing or magnets in India? I think there is, at least the thinking is there through like a lot of programs that are coming up, but it will take some time for sure. But the other challenge is from the servicing point of view, that do we have the enough local technicians or service technicians on ground in India who can make sure that they can go and fix a BLDC motor fan. And even for the room air conditioner sector, if I say, what is the current state of in terms the resources that are need to work on these room air conditioner, which are in the tune of like 40 million currently in terms of stock, but we are talking about like almost like 500, 600 million ACs in the future. So I think training the service technicians, certification of service technicians for both room AC sector and for this ceiling fan sector is something that we need to focus on. I'll keep my initial remarks to that if that is okay.
Yeah, thank you so much, Jerry. Pradeep sir, moving on to you. Would love for you to elaborate more on what are the key bottlenecks currently in the entire supply chain, and how can we promote collaboration between the OEMs, ODMs, local suppliers, policymakers to streamline the entire HVAC supply chain ecosystem?
Yeah, first of all, I wanted to thank AEEE for giving this opportunity to talk about this very relevant topic of HVAC and the localization and creating a ecosystem so that the manufacturing can happen, because this industry is going through such a growth which is so phenomenal that the whole world is looking up to India to do something in this area of technology. And hence, because of that, World Bank is also interested to work with the government of India on a program called as AHEAD, which is essentially looking at how we can create a local ecosystem which will help spur this industry in a very big way, not only for India, but probably it becomes the hub of exporting these products outside India, right? So I think in that context, and also what Jerry rightly pointed out, that, you know, we all know the challenges, right? We all know that what are the challenges at the level of manufacturing in terms of the room air conditioner, and partly it will also apply to the ceiling fan, especially the new technology like BLDC or something new also which is going to come, right? So if I look at RSE, some of the learnings will be applied for ceiling fan. In RSE, there are 3 types of ecosystem players that we have to understand first. One is that there is this global companies, which are Japanese, Korean, Chinese, and American, which already have their own design of their compressor, their own design of their controller, and they may be sourcing or making them in-house, but the costs are essentially in their control, right? In terms of the input that goes inside, because they are more or less controlling the design, they are controlling the manufacturing and the assembly of the same, right? Then there are these second set of Indian players, example is Voltas, Blue Star, who depend on the global supplier ecosystem of the inverter compressors or the controllers that are required to drive this inverter compressor. And driving essentially is driving through the power electronics module, which is driving the BLDC motor of the compressor, and also the control system to operate the various aspects of the air conditioner, right? So these people are dependent on a few monopoly companies from whom they have to buy this compressor and the inverter controller, right? And then there is third set of players who are supporting the MNC companies as well as these Indian companies in the form of OEMs, ODMs, where they are saying that you have limitation in your capacity in your factories, we will support you with the full product or a kit or a partial product. Somebody will be wanting only a indoor unit, somebody will be wanting an outdoor unit, somebody will want a paired unit but maybe without refrigeration. So all those combinations is what the OEMs and the ODMs are supplying. There was a fourth player, which was essentially the CBU, which is the completely built unit. Fortunately for India, it is banned now. So nobody can import a completely built unit in the room air conditioner segment, which is also helping encourage the players, right? But there are still some small shipments happening where the CBU is coming without a refrigerant, and these OEM, ODM players are, using them. So the challenge of all these three are different. So there is no common thread among the global MNC companies or the local Indian companies or the OEM, ODMs to come on a platform, common platform, like how automotive industry does, right? Where they can say that here is a problem that we have, here is a market which is huge and it is now going to explode in a bigger way. This year itself we are talking of, 1 crore air conditioners being sold, right? It's a phenomenal thing which is happening. The growth is phenomenal. But there is no common platform to address and say that let's build a compressor which is designed in India, which is manufactured in India for Indian tropical condition. What do I mean by Indian tropical condition? Indian tropical condition is very high ambient, distributed across 5 different temperature and humidity zones in India across seasons, right? So we in India also use the air conditioner for the full year in coastal cities and even in monsoon in cities like Delhi and other dry cities, right? So combination of that in terms of designing a product. And the second part is that, okay, we may not be able to come to a stage where we are going to design a local compressor, local controller, but can we look at getting beyond assembly? Presently, we are only doing assembly of the air conditioner part, where 70 to 80% parts are locally, sourced from the outside India and mostly monopolistic suppliers, right? So the thing to evaluate and consider is that how do we have an arrangement where the overall market is aggregated by an association or an organization which is saying now this is the available opportunity, this is the available market, and this is the challenge that we have today. Let's build something together so that we can, and that's what is one of the key deliverables of the AHEAD program, right? That we want to do that and make that ecosystem created in India, right? So that's the first aspect of looking at how do we localize whatever is available in India, within India, right? Now, if it is not available in India, is it available outside India where somebody is ready to set up a manufacturing setup in India, not only supplying to their own base, which is their own companies, but also to others at a very competitive rate, right? So one of the example is Daikin, right? Daikin has so far been very insular in terms of not wanting to open up their compressor availability for companies beyond Daikin. But now they have tied up with a Taiwanese company, and the setup in India, US, and multiple places is going to happen in terms of local manufacturing, where they will be ready to offer this compressor beyond their own customer base or their own brands also, right? So I think these type of steps and initiatives which are happening in bits and pieces, if we can create an ecosystem that it can happen in an organized way, then automatically, like the automotive industry where a Fiat engine is being used by a Toyota, by a Honda, by so many companies, and they have availability of that type of an engine with technology levels in terms of handling pollution, efficiency, etc. at various price points, right? So I think that sort of a democratic availability of compressor and inverter controller technologies as well as manufacturing should be available to the public to either in a kit form where they can start assembling it locally, initially maybe CKD, SKD, then the full assembly can happen, right? So on the compressor and the controller, this is the story. Now let us look at the other peripheral parts, right? It's an irony that we are the largest mineral resources of steel, copper and aluminum in India, but all this raw material goes back to the countries outside India, in Japan, Korea, in China, where they come processed back in the form of a grooved copper of 5 mm, 7 mm, and finned copper of a particular thickness, of a particular property which can help do heat exchange in a better way, right? So what are the alternatives to localize these with partnerships in India and make not only the component but also make the machines which make the component, right? Because as soon as you localize a 9 mm or a 8 mm or a 7 mm copper coil, the 5 mm is going to come, or the 4 mm or a 3 mm is going to come, a grooved copper with new design is going to come. So having that continuity of manufacturing will also help in building this actually.
Great. Thank you for the detailed answer and explanation to the very complex problem, Pradeep sir. I'd like to move on to Akash, you, and understand if there are any plays for alternatives to reverse Carnot cycle based HVAC&R systems with high SEER. And if yes, how does the landscape look for commercialization in the next 3 to 5 years?
Okay. So thank you so much. I'd like to thank AEEE for considering alternate technologies as part of this session, because I think that is one component that is going to achieve highest energy efficiency in the coming years from the point of view of lowering the global warming potential refrigerants and increasing higher efficiency for the refrigeration systems. So yes, there are many alternatives to reverse Carnot cycle, and these are typically thermal driven systems, both absorption and adsorption, and also thermal you have the solid state cooling technologies like thermoelectric, and these are very specific technologies which are very appealing to the current environment because they don't use the synthetic refrigerant, and because of which they are able to today compete head on with conventional technologies which use very high global warming potential refrigerants. But there are many challenges for them, for the alternate technologies to commercialize them today on next 3-4 years because they are done in very small scale. So I think number one is the performance enhancement of the alternate technologies, and this really depends upon the R&D that we are doing on material sciences. That would increase the coefficient of performance and also the ICER. Second is these alternate technologies are today very expensive. They have a premium of 2x, 3x compared to the conventional technology. And to make it cost competitive, we as a manufacturing company or as a policy maker or as a country need to invest highly on R&D and manufacturing to increase the scale of adoption. Third, from the policy point of view, we need support from the policy makers to promote low global warming potential refrigerants. And I think if that is much needed, and I think that will not only encourage the manufacturers but also inform the end users about the refrigerants like R22 that has already been phased down. And unfortunately, in the Indian market, it is being promoted, though it is still being promoted as an environmental friendly refrigerant. Again, so for commercialization of these alternate technologies, we at New Leaf, we are looking at very specific niche applications, and these applications are in the segment that are highly dependent on power. There's a very high cost of cooling because there's no availability of power. They require diesel generator, and they are in the middle of the farm. So some of the applications of we at New Leaf are developing and have developed and deployed on the field from the adsorption cycle is cold rooms for the farm gate. We also have developed ice plants for the fishery segment, again closer to the coast where the availability of power is very low. And one other interesting application that we have been working on right now is providing comfort cooling through a liquid desiccant technology for the construction workers at the sites where there's high humidity. So such applications are required to seed in the alternate technologies, and this will further help adapt it in the years to come. Thank you.
Super. Thank you for that, Akash. Snehal, next question is for you. What are the effective measures to facilitate, like Pradeep sir also mentioned, right? Manufacturing of compressors tailored to India's specific climate needs, and how can we get the operational rigor for RAC and then other HVAC&R devices?
First of all, thank you AEEE for inviting Alpha Laval for this very important panel discussion. Before going to the main point, let me correlate few things for India. The first thing, India has participated in Paris Agreement. That's why NDC says that 2070 is India's net zero commitment. We all need to know that India is third largest CO2 emitter. And we all know that room air conditioners market, split AC, ductable, tower, cassette, chiller, industrial chillers, this will not stop. And with CAGR of 12% plus, it will keep on increasing. The number what we have today is 1 crore air conditioners, 10 million units. And with this CAGR, this number will cross 2 crore by 2030. So do we all know that these many air conditioners, these many room air conditioners, the chillers, how much power it will consume? This year, the report says that 190 terawatt hours. 190 terawatt hours is a huge number in terms of electricity power consumption. And do we know that India's power generation capacity, renewable energy capacity, this power consumption of HVAC industry relates to carbon dioxide emission, and which is part of India's commitment. India is going to meet 2047 as energy independence year of India, 1947, 2047. And that's why 2030 doubling the rate of energy efficiency is paramount important, being a first fuel of a decarbonized future. When I say 190 terawatt hours, that corresponds to somewhere around 22 gigawatt of power. So such a massive volume of air conditioners and chillers in Indian market requires really localization and partnerships so that innovations, developments can happen in this space energy efficiency can come in picture, because we cannot stop anybody from buying air conditioners because it has become a part of comfort cooling. The life is not easy without AC. 10 years back, what was the weather, temperature we enjoyed? Even before 10 years, our school, college days. This is not today. And tomorrow, after 10 years, the new generation, young generation, they will not have the same weather. So the air conditioning and refrigeration industry will see a massive boom growth, but without energy efficiency, the survival is very difficult. And that's why partnership, joint ventures, localization of compressor manufacturing, localization of screw rotor manufacturing, because assembling a screw compressor in India is easy, but how the rotors would be made? So we are dependent on European nations. Why can't India make a joint venture with Europeans, develop the technology in India and meet local market requirement? Creation of job, energy improvement, energy efficiency and meeting the market demands. These all multiple objectives can be solved, because this industry is again a big power guzzler. 22 gigawatt is a huge number taken by this industry. Thank you.
Thank you, sir. Jerry, I'd like to come back to you. If you can just comment on what is the adequacy and preparedness of Indian companies for manufacturing some of these newer technologies as well.
Yeah, so I think I'll start by saying, like, transitioning to these super efficient cooling appliances or products, it is not only a technological problem. It's about how do you make sure that this energy efficient product is accessible to all. So if you talk to the industry, the first thing that they'll say is, like, the industry is totally market driven. And to make sure that any super efficient product penetrates into the market, I think what we need to understand across all the available alternatives, what is the TRL and CRL level, what we call, in terms of the technology readiness level and the customer readiness level. So even, I think from an industry point of view, if we tell them that you have to make a 8 ICR or a 10 ICR room air conditioner today, they will make it. It's no doubt about the technological aspect on that. But in terms of selling that product and how it will penetrate into the market, I think that is something that is totally cost dependent, and the cost of production of these super efficient product has been always high. And I think it's about realizing that there is a scale in terms of what we are talking about, the cooling demand increase and the opportunities that lies in front of the industry as well. But even though there is a scale, how do we make sure that the customer readiness level and market dynamics plays a pivotal role for them? I think that will be important.
Thank you, Jerry. Pradeep sir, next question I'd love to understand from you, and we've covered the AHEAD program with World Bank earlier as well, and we are super excited to be a part of that initiative as well. And I'd invite a lot of you all to join that initiative, because a lot of our consultations and insights from this discussion will also feed into our AHEAD program, because that is one of the ways that we can set up a platform to facilitate some of these partnerships between local industries and global technology providers, and have some sort of bilateral trades and joint ventures. What I'd like to also understand from you is what Jerry mentioned, right? How can we augment this customer demand for high efficiency HVAC&R solutions, and like amongst all retailers, consumers, how can we evangelize these high efficiency benefits to the planet in terms of the long-term cost benefits as well?
So I think what Jerry said was absolutely right, that the price difference between a 3-star and a 5-star is very high, but I will not agree with him that the input cost of that is in that same proportion, right? So I wanted to put this on the table for the audience to know that the cost difference between a 3-star and 5-star is not as big, but the price difference is very high, what the consumer is paying, right? So First is that needs to sink in, and this is a typical business, wicked business problem, right? Businesses are here to make money, they are here to make gross margins and be answerable to their shareholders, right? So they need to find out where is the sweet combination of the pricing and the distribution of the product mix, which will give them the right gross margin and the top line, bottom line is balanced, right, in terms of their objectives. So we can't go there, right? We cannot go there. But what we can go and talk to the government and ask them for support is that wherever there are these institutional sales happening, and wherever these big contracts are being negotiated for setting up air conditioners for new offices or SEZs that are coming or new installations which are coming at a very large project level, if we can have mandates being set up in terms of telling that, you know, here the 3-star will not work and a 5-star will work, right? So the mandating is required. In addition to that, there is a big elephant that we have in the room, which is in the whole country, is old air conditioners, right? Fixed speed air conditioners, 1-star, 2-star, 3-star, old 3-star 10 years ago, 15 years ago. Who is going to address to replace those markets, or they're going to die their natural death? Like the automotive industry, we also need to look at what is the mechanism to either recondition them so that they can come back to the higher energy efficiency level, or reuse them, repurpose them, or they can be, be part of the market which is added in the kitty of the manufacturers to have a higher volume of the 5-star ACs, for example, right? Then they can't speak about that the volume is so less, the market penetration is so less. The market suddenly opens up in terms of economies of scale, right? So that's the way to look at how to, adopt and help bring. Another elephant again back in the room in the country is how about taxation mechanisms, right? Do we have 28% for air conditioners which are 3-star, 2-star, but a 12% or a 5% or an 18% for a 5-star, and maybe 6-star, 7-star, 8-star will come, where you can have an 8-star with 5% GST, right? So you are automatically creating a level playing field for the consumers to choose, because now there is a competitive product available, but it is taking benefit from the way that the government is pushing, right? So I think these are the set of things that we can do which will help you enhance. And then last but not the least, if you look at the training that my air conditioner company is providing to a retailer or to a dealer, distributor or a service network, they're only talking about the product. Can we also talk about the planet? Can we talk about what are the benefits of having a 5-star AC being used today, that many less number of power plants, that many less number of power cuts during the peak summer in Gurgaon or any such city? Even now during summers you have ACs running on generators, right? And generators are very expensive in terms of running air conditioner during the peak load, right? So we can also look at evangelizing the benefits at a retailer, customer, distributor level, and also evangelize the ROI benefits of a 5-star AC in terms of the life cycle cost, right? So I think if we do these kind of things, and that too at a programmatic level with World Bank or AHEAD or any such government large initiative, it should be possible that we will take baby steps in that direction, and then maybe the step change will happen by the society which will bring that change.
Thank you for sharing that, Pradeep sir. Snehal, next question I'd like to come to you would be around, since Pradeep sir brought out a couple of elephants in the room, I'd love to understand from you on how e-waste and green credit programs can be designed to replace these outdated legacy rack systems of low energy efficiency with high efficiency ones.
In this case, like ESCO companies can bring in the difference because they are the forefront for the industry, and they can approach the industry, educate about the power consumption, educate them about sustainability. And this kind of education will certainly make the industry aware to come out of the old traditional technologies and offer higher energy efficient solutions. And plastic content is not high, but metal content is good, and everything can go into recycling. And newer air conditioning, as against the buyback of the old non-performing, less energy efficient, some sort of subsidies will encourage them to opt for that. Another thing what the industry can do is like group purchasing, group buying, ask for the larger discounts so that most energy efficient product goes to the market. Second, what industry can also do, the way like what Alpha Level does outside India is district heating and district cooling. So India district heating is not applicable, but definitely district cooling is applicable. So we can create sustainable cities. So a group or a society of 80 flats, 80 air conditioners, someone will buy 3-star, someone will buy 5-star, and someone will even not bothered about the star rating. But if that building decides to have a district cooling kind of setup at the basement or at the terrace, the overall utility area and the air conditioning power consumption will drastically come down. And this sort of suggestions, it comes from the local municipal corporations or government bodies, overall city will become a sustainable city, and that will meet the objective what government is looking for.
Thank you, sir. Akash, last question would be for you around how we can foster standardization and bolster the overall domestic R&D with the entire efficient cooling ecosystem for us to, one, drive formulation of progressive policy frameworks. Second would be to facilitate conducive ecosystem for the efficient technology adoption. And third is again enable a cycle of continuous improvements with, every new technology like Pradeep sir also mentioned that comes into place for HVAC.
Yes, definitely standardization and the domestic R&D can transform the HVAC&R industry. Specifically, the benchmarks like ICER and adoption rates of low GWP refrigerants. This will help policy makers to set up clear goals and enforceable goals for the manufacturers and the end users. Number two is when the technology is developed and tested locally with the local standardized protocols, it brings confidence to the industry, manufacturers, end users about its reliability and efficiency. Third is standardization. It will reduce the market fragmentation, so helping in the scale up in production, reducing the cost of the high efficiency systems. And fourth point is that we need domestic R&D, and domestic R&D is the only way that can help us further refine the products. So as you mentioned, it is going on outside India. The technology is developed outside India. They develop it to their own environment, temperature conditions. But in India, we are totally dependent on the products that are meant for the European or the other South Asian markets. So we need to further refine a product based on the domestic R&D. And I think the policy makers should incentivize it and also help bring forward the public-private collaborations. And this will help initiate the R&D, the domestic R&D, which will help bolster the standardization and driving the HVAC&R market. So again, to summarize, at New Leaf, we feel like a lone player using a renewable source like biomass because the norm says solar, but while using biomass, it is considered renewable. We feel that not much has been done or needs to be done on the policy side to enlighten not just about solar but about the biomass aspect too. Thank you.
Super. Thank you. We'll move on to the audience questions now. So if anyone in the audience has any questions, would love to hear from all of you all as well. Yes.
As you mentioned that there will be 1 lakh over millions of room air conditioners will be sold, but we are finding that in the industrial, applications, we are finding that most of these HVAC systems, basically where the gases are waste to energy solutions are used, where these gases are repurposed, or basically used for some other application. Same is the case with liquids also. But that sort of, innovations are not there in the air conditioning market, room air conditioner, where basically just standard products are sold, because in future there will be a lot of emissions and a lot of, greenhouse gases because of that reason. Because and a lot of technology has to go in that area so that waste to energy can be, used as a sort of.
So, who is this? If you can introduce yourself, sir.
I'm Manish Sharma.
From?
Well, I'm working as a consultant, yes.
Okay. So, Mr. Sharma, to answer to your question, you are absolutely right that in the industrial HVAC system or the cold chain or the district cooling system, if you have to reuse or if you have to, have the refrigerant, the storage of that, the collection of that and reuse and cleaning and reprocessing is possible. But in a room air conditioner, which is like 800 or 1000 grams of refrigerant, with new refrigerants is even less, 300, 400 grams of refrigerant which is there. It is difficult to, store them at such a small level, right? But again, the same question that happens is that if you look at the mandates that we are talking of, can we start this kind of a mandate at least for big offices where there are thousands and thousands of air conditioners available, where the EPR norms are already in place for that office or factory, right? For example, if you talk to an Infosys, they are already certified in terms of the water use at a very high level in terms of the way they efficiently manage the source of water, rainwater harvesting, etc., right? So you are right that the policy level change in terms of you cannot throw the refrigerant to the open even if the AC is not in use or is being reconditioned or reused, is something which can be started with bigger offices which have multiple installations, and an EPR norm can be created. And this is a good input which we will take also in the industry discussion that we have as part of the HEAD program, because you are right that the refrigerant is in such a small quantity, but it is in large number of machines, right? And it is decentralized and distributed. But at least we can look at the centralized ones in terms of offices and factories. Good question.
Thank you. Anyone else has a question for the panel? Also, I'll request you to introduce yourself before the question.
I'm Kaparti. I'm a co-founder of Powerka Energy. My question is, the labeling standards have lagged behind the technology curve. How fast do you think that has to evolve basically to set an ambitious target, given the volumes we'll see?
Yeah, so particularly, for example, if I talked about the standards and labeling for room air conditioners, right? If you compare it with global standards, so firstly, like the metrics that are used across different countries is totally different. Like there's EER, there is seasonal performance indicators, and there is ICR rating that India use. But it is about what is your MEPS, right? The minimum energy performance level, and what is the 5-star. And like everyone knows that 3-star is the biggest market. So I think from my understanding, how the SNL should evolve is, firstly, from an industry point of view, there should be a long-term vision in front of them from the government. Like, for example, if Bureau of Energy Efficiency is revising it every 2 year, 3 year, but at least there should be some vision of like what does the standards look like in like 10 years from now. You at least give that vision for the industry to like set up their infrastructure facilities according to the ICL level that at least the government is thinking about. So that leeway will help them to at least do some R&D. So that is the first thing. Even if you want to now put the 5-star as the best available technology, even if it is global, I think that is fine. But at least they should give that time or at least that vision that, okay, from 5 years down the line or 10 years down the line, we want to achieve that ISO rating of 8 or 10. So that long-term vision will be helpful from an SNL point of view. For the maps, I think it's very debatable that how even like currently understanding that what the 1-star market look like, for example, room AC, if it is very low, then at least we can push out the 1-star and maybe bring it to like 2-star or 3-star. But I think there, like any country will look at like how the economics is playing and how the basically the impact on the production and even the sales of the industry as well. So, but I think somewhere the best available technology, if that can be made the 5-star of the country, I think that's one way to go.
Thank you, Jerry. Any other questions?
Hi, my name is Amrit Raj. I'm from IIHS. So my question is, while we might incentivize companies to manufacture in India, how do we incentivize the companies who purchase these components to not import it from outside India, where it might be cheaper for them, and ensure that they purchase from the Indian manufacturers?
It's a very good question, sir. And I had already made a brief mention that in India, now the completely built unit, which is the CB unit, is not allowed to be imported from any country outside, right? So that's the first step the government has taken in terms of not allowing the complete indoor unit and outdoor unit to be imported, right? The second step is that if I want to ban a compressor or a controller being not purchased from outside India, for example, then we need to have captive capacity to address manufacturing of 1.5 crore compressors in India, 1.5 crore controllers in India, right? We do not have that capacity. So the government is looking at this problem, that how to build this capacity so that slowly the phase out can happen. And now also for you, to give you a heads up, all the big companies have been told that if they have a mother plant in a China or their mother country, they are supposed to set up their plants in India. So Daikin is setting up its own plant, LG is already set up its own plant, then Highly Hitachi is set up in Ahmedabad, GMCC is setting up a plant in Pune. So those kind of steps government is taking. And today if you look at the controller, it is not being sold as a full product, it is being sold as a kit to many OEMs in India who have good scale and volume, right? So the steps are happening, but these steps definitely, I would agree, are not enough. We need to take more steps to create the real push and the demand for buying it locally from India.
Super. We have just time for one more question. Let's take the two questions together and we'll answer them together as well.
Good afternoon. I'm Sumit from Renasa. My question is that, as you said, that the localization in HVAC is about 70 to 80%. Most of the critical components are still not local. If I draw a parallel with the automotive industry, which is fairly successful in localizing a lot of critical components. Now that we have size and scale in HVAC industry as well, not just now, for the past 5-10 years, what do you think is the main reason that this particular industry is far behind, let's say, automotive industry, with which we can draw a parallel?
So do you want to take the second question as well?
Yeah. What's the second question?
There was another person with their hand up.
Hello, myself Pankaj Kewal from BP Refcool, and I am working as an employee. So my question is like, is there any product or any way which can help in improving the energy efficiency of HVAC chillers? Like there is a leak in the chiller, consumes so much energy, and if there's a low refrigerant level, it also consumes so much energy. Like if there's any product or any way which can help in improving the energy efficiency of the HVAC chillers.
Yeah, so I'll answer the first question first, and you are absolutely right that I would use the sentence, the automotive industry has earned its place in terms of the mature ecosystem that is there in the automotive industry. So the question to ask is the HVAC industry mature enough to have earned that place in terms of saying that we are now at a stage where the market is available, there is a demand, and now we need to do. Yes, the time has come now, and the steps that we are trying to take as part of the AHEAD program, as well as more programs to the government, one of them is to create an ecosystem which is as mature as an automotive industry, right? But we are at the beginning of this, right? We have not even started to make baby steps in that direction. But the ultimate objective will be, if India wants to become an export hub of room air conditioners as well as the cooling space leadership position if it wants, then it has to have a status of an industry and a status of the set of ecosystem in terms of associations, testing laboratories, etc. But we are not yet there. Definitely there is a need, but we are not there. You have an additional question? Yeah. Yeah, because, so that was the reason I was telling that if you go to the industry champions and talk to them, they have been waiting for this movement in the HVAC industry for the last 30 years, that the critical market setup and the market volume would build, right? Now is the time. That is what every industry leader is talking about. You talk to Daikin, Blue Star, Carrier, they say now is the time. Now we will do it because the market is quite ripe and big enough. Maybe the time and the market was not right. Now this will start. That is what I'm trying to say.
Would you also like to address the second question?
Yeah, the second question was regarding HVAC and chillers being built in an efficient way, like that was the question. So if you look at the journey of RAC, right? RAC was predominantly fixed speed for, from 2010-12 in that area. The inverter technology got introduced and the labeling program was kicked in. It has taken 10-12 years for the fixed speed to be from a 90% dominant market in 2010-12 to being less than 10% now in 2025, right? So it's a journey. So while there is critical mass available in the journey of the room air conditioner, the similar critical mass will come in the cold chain, HVAC chillers and the commercial air conditioners, as well as the market explodes, right? So definitely market forces are driving, and secondly the learnings from the RAC industry will also help us push. So this is also part of our program in AHEAD, where we will not only look at room air conditioner but beyond that in terms of cold chain as well as DCS and other systems, where we can apply these learnings of building energy efficient devices beyond the RAC. Definitely this problem is there, but maybe the critical mass and adoption is not there. We need to focus on getting that right first.
Thank you. Thank you to the entire panel. It has been wonderful talking, about HVAC and how we can localize, what can be the different pathways, what are the challenges that the overall industry faces, and how India can be like a global player that can be looked up to as a major manufacturing hub in the coming years. So thank you for sharing all your amazing insights, and I'll request everyone here to look up and contribute more in whatever different capacities you all are playing as different industry players, and coming together as an ecosystem given the time and the market is ripe. And sir also mentioned we have the AHEAD program, which is also aiming to do the same with World Bank. So with that, we conclude the session for today.
Thank you so much for that. I'd like to invite our panel for a group photo. To felicitate our panelists, I'd like to invite Dr. Ranavir on stage. We're going to take a pause for 2 minutes to just reset the stage. I request everyone to remain seated while we do that.